Okay, sorry. In class, we weren't able to finish examples 4, and so we're going to finish example 4 of 2B.3 part A. So on example 4, we were sketching out our function and the y equals x line and staying in the domain. So I'm going to sketch out my y equals x, which is the invisible line of symmetry that I want to create. So I'm going to okay, that's in there. And now we're going to sketch out the function and state the domain and range. Okay, so here we have a cube root function, x plus 2 minus 1. For the cube root function, it's going to be your parent function of the cube root. So the parent function of the cube root, if you think about the values of it, it's going to be 8, yeah. So we have -8, -1, 0, 1, and +8. So the cube root of -8 is -2. The cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So if you look right here, this is the transformation of that function. So here it says that I'm taking these values and I'm shifting them 2 units to the left and down 1 unit. So each one of these values is going to go 2 units left and down 1. Well, clearly -8, -2 isn't on here, so there's no point in me starting there. But I can start at -1, -1. So I'm going to go, I originally was at -1, -1, but I'm going to go 2 units left, 1, 2, and then I'm going to go down 1. So -1, -1 is now here. Okay, I'm going to go to 0. 0 is going to go 2 units left, down 1. So here is now 0. I'm going to go to 1, 1. Going to go 2 units left and down 1. Okay, when I'm graphing this out, I'm going to do my very best to keep in mind where this would be, right? So if I was at -8, -2, if I could graph it, I would be at -10, -1, right? And so, sorry, I said -1, -3, -3. And if I could graph this one, moving it 2 to the left would put me at 6 and down 1. So 6, 1. So I know that if, as I'm graphing, I'm not going to go above 1 here, and I'm not going to go below 3 because I can't even get to those points. So it's looking something like, I'm going to even take it off the page to try to show you. Oh, I tried. Let me do that again. We didn't make it. We didn't make it. So we're going to, again, I'm going to go here. I believe in me. Oh, and we keep going, right? So there is my cube root of x plus 2 minus 1. So looking here, the domain is going to be -infinity to positive infinity, and the range is also -infinity to positive infinity. Okay, now it says find the inverse and state its domain. So we're going to find our inverse. To find our inverses, we're switching our output with our input. So that's going to give us x equals the cube root of y plus 2 minus 1. My goal is to get y by itself, so I'm going to add 1 of both sides, and that's going to give me x plus 1 equals the cube root of y plus 2. Then going to take the cube of both sides. So I'm going to take the cube of both sides. And we're left with y plus 2 equals x plus 1 cubed. I'm going to subtract 2. When I subtract 2, that's going to leave my y by itself. So this is going to be my inverse equals x plus 1 cubed minus 2. Okay, so now I'm graphing a cubic function. Okay, and luckily enough for us, the cubic function, its starting points are also -1, -1, 0, 0, 1, 1. X, instead of it being horizontal, it is a vertical. Okay, so now I am shifting everything left 1 and down 2. So we're going to go left 1 and down 2. So instead of being at -1, -1, we're going to go left 1 and down 2. Now, with that in mind, you also can just look at this and flip the inverse. So if I'm at -3, -2, then my inverse is going to be at -2, -3. If I'm at -2, -1, my inverse is going to be at -1, -2. If I'm at -1, 0, my inverse is going to be at 0, 1. Okay? Same thing here. So these are switching, -3 and -10. So when I am looking at my values, I know that -3 is over here and it goes all the way down to 10. So I clearly am off the page somewhere down here, living my best life, coming up here. And then I'm going to cross here and I'm at 6, 1. So 1 goes all the way up here to 6 somewhere. Okay. So as you can look here, pretending that your teacher did the most amazing job of drawing symmetrical, you can see that visually they are reflections across the y = x line, which tells us that they are inverses of each other because of that reflection across the y = x line. And again, the domain and range is going to be both from -infinity to +infinity. Because the function goes forever to the left and forever to the right. And yeah, so here are my two functions. Algebraically, I would substitute in and simplify to prove whether they are inverses. And when I would plug in to find the inverses, I would end up learning that composing them together, it's going to be equal to x. So G composed of what we got as our inverse is going to equal our inverse composed of our g of x, and they're both going to equal x. But again, visually, we can see that they are inverses because they are reflections over the y = x line. And they are both one-to-one functions, so they are actual functions and not just relations. All right, that's it.